Okay, so now what we're going to do next is, instead of just looking at one draw, I'm going to go back to 1,000, so I don't know how long this takes to run. I'm going to look at two draws, two random draws, and I'm going to take their average.
Okay.
Okay, so now, just to be clear, what I'm doing is I'm selecting one random number from 0 to 1, another second random number from 0 to 1, adding them together and taking their average. And then I'm doing a histogram, so I'm looking at the distribution of outcomes.
Yeah.
So what is your guess as to what this is going to look like?
Well, I think it might be the same-ish, maybe a little less distribution, or a little less randomness, because maybe sometimes you could get a low number and a high number, and then that would kind of cancel out the variation. But you could just as easily get two low numbers, like below the average, or two high numbers above the average, and I don't know. I don't think this will change the randomness too much, but maybe it will.
All right, what do you think?
Oh, I actually think it'll start to form sort of a curve, because a while ago I did things called like dice races, where I rolled two dice and basically plotted the outcomes, and there was a large bias towards the numbers in the middle, because I don't know, if you rolled, I think there are more ways to get them, because you have to roll like two high numbers to get a high number and two low numbers to get a low number. I think that'll sort of be the same in this distribution.
Okay. What do you think?
I guess that makes sense. Like if you're trying to roll a 12 with two dice versus if you're trying to roll like a 6 with two dice, there are more ways to roll a 6.
All right. Well, here's our first shot at this with 1,000 draws. So, what do you think?
Yeah, it's sort of like what I saw. It's not the same shape, and not the curve isn't the same shape, but the outcome is sort of the same. Yeah.
All right. What do you think?
Yeah, and I think we have a general curve here, but we still have a pretty significant amount of variation. I mean, it's not like this down here is random chance, so I don't think it would be, but like something like this is probably abnormal.
Yeah, let's run this, well, probably not too hard to run 100,000 times and smooth it out.
Yeah, so it's weird. Well,
It actually that doesn't look like a curve. It just looks like sort of a triangle. It's sort of like almost a solid edge.
Yeah. It's not really like a normal distribution that we're used to seeing, but it's just kind of like a triangle.
Yeah, why do you think it's well, let's just assume that it ends up being that triangle. So essentially the distribution is two straight lines. Why do you think it would be like that?
I guess the probability of rolling in or ending up in one of these buckets from the sum increases by a constant amount every time, so maybe there are just progressively more ways to do it. I don't know.
What do you think?
I mean, I guess we're not really working with multiplication or any sort of exponential functions here, so maybe it's just linear, just because we're using addition. That kind of makes me wonder, we could test that by doing t times t to the 1/2 and seeing what that would be.
Okay.
Maybe if that's any different.
That's a great idea. It wasn't what I was going to do next, but I'm definitely happy to try that out. So let's go to the next video.